Welcome, Dr. Paul Swan. It's wonderful to have you here today. Thank you for doing another webinar. And today we're developing number sense with a number board. So anyone that wants to participate at home, strong suggestion is to go to the website and download a number board. So 1 to 120, I should say, not 1 to 20, number board on www.drpaulswan.com.au, and you'll find a number board, which Dr. Paul Swan will show us in a moment. And best things to have is a few counters and a pen, a dry erase board, pen or a pen. So thank you. I'm going to hand it over to Dr. Paul Swan.
Thanks, Heather. And look, we're trying to keep things fairly simple today. And essentially this idea of number sense is really having an understanding of number, being comfortable with number, and then being able to use that ability to do things like estimate, to understand place value, to build some ideas like your basic number facts, and even to look at number patterns or the development of algebra. So we'll be going through those sort of topics today, and we're just going to use a very simple piece of equipment, which is a number board. Now, I like to go beyond 100, and that's why we're using one that goes to 120. So you'll see it there at the moment. And essentially, the reason I like to go beyond 100 is many children, when they learn to count, they stop counting at 100. And so they'll go 100, and when they go beyond 100, they go up to 109, and quite often they then go to 200. So basically, I just like to go that little bit further. The second thing is you start to see that certain patterns go beyond 2 digits and into the hundreds and so forth. So I thought we'd start with a couple of simple ideas that might build on that. And the first one is really, some people call it guess my number or find my number. And the nice part about that is that we're giving certain clues, and the clues will help us to identify a number. And the clues that we give can either be in written form or oral form, and they build the mathematical vocabulary of the children. So I'll get you to focus on the number board, and I'll take you through a couple of clues just to show you how this idea works. Now, I'm going to be using a dry erase pen and a laminated board or a whiteboard here, but you could do the same thing with your standard board there. So the other thing I should mention, the reason I like this size board, and you'll see the counters here, is that your standard 19mm counters fit nicely over without bumping into other counters. So that's why I like this size board. But let me take you through this idea. It's a find my number or guess my number, and I'll give you a couple of clues. For example, I might use, or I might give the first clue is, I am less than 40. So if I'm using a clue that I'm less than 40, essentially I've knocked out everything that is above 40. So we can now forget everything that is in one section of the board and narrow down our search. So the first clue was I'm less than 40. Let's have a look at the board again and just see now how we can give more clues to help identify what the number might be. So I'll focus you back on the board, and we're going to look at this notion of now, you can see here that I've got all the numbers that are less than 40. You can see very clearly what they are. But here's my second clue. I'm a multiple of 3. So I could use counters, but I'm just going to put it here. So you can see it's 3, 6, 9, 12, 15, 18. And you start to see a pattern develop. And after a while, you can see how this pattern works across here. And so these are all of the multiples of 3 that I can see here at this moment. So the multiples of 3 would be 0, 3, 6, 9, 12, and so forth. So I'm learning that basic idea. So now what I've done is I narrowed it down further. So the number is less than 40, and it's a multiple of 3. Now let's add a further clue to this idea. So I'll head you back to the board and see what this next clue does in this one here. So we're looking for things that match all the criteria. So ultimately at the moment, anything that's not in this set here, so they're no longer in play because you have to be a multiple of 3. So that knocks out all of these numbers. But my next clue is you also have to be a multiple of 4. Well, that really narrows it down a bit because now I'm looking for something that's a multiple of 3 that is also a multiple of 4. And what I'm going to do is I'll put a counter on there. So a multiple of 3 and a multiple of 4 is 12. And another example of that. So we now, what's another multiple of 4? Well, I've got 16. No, I can't use that one. 20, can't use that one. 20, another one would be 28. Another one would be 32 or 36. So that's another multiple of 4. So if you look back now at the board, you'll see that there are 3 counters that are sitting on there. And if you spot them there, they're on the numbers that are 12, 24, and 36. So you can start to see I've used my language. Remember the first statement was I am less than 40. I'm a multiple of 3. I'm a multiple of 4. And now the next expression is my digits add to 9. So if I look here, 1 and 2, that adds to 3. 2 and 4 adds to 6. But 3 and 6 adds to 9. So I could remove those two and the answer would be 36. So you start to see how just a simple exercise like find my number or guess my number builds a strong mathematical vocabulary. And mathematical vocabulary is extremely important if we're going to develop really good number sense. So that's just a fairly simple idea. Now, obviously, it'd be really good if children develop their own version of this. And the way you start is you work backwards. So you start with the number and then you write clues that allow you to get to that point. So let's have a look at a couple. I'm going to clear this board up with another board. We'll have a look at a couple of other activities that we can do. But I like those sort of these whiteboard versions because it just allows me to have more flexibility. Let me pick another example. And it's just simply going to be that I'm going to roll with my dice. I'm going to roll 2 10-face dice. And they go from 0 to 9. And they will generate a 2-digit number. And then we're going to find that on the number board. And then once again, we're going to talk about some numbers that come before or after or between and so forth. So the board's cleared again. So we'll just go back to the number board that we have and you'll see what I mean when I roll these dice. So away we go. So I roll the dice and I have here, you may or may not be able to see it, but I've got, so we've got in this case here, 69 might be the number that's come up. So if I've got, is the bit there, so I'm going to put here, so there's my counter and I'll put it on 69. Now I could ask some questions along the lines of, what is the number that is 1 less than 69? What's the number that's 1 more than 69? What's the number that's 10 less than 69? 10 more. Now, if you start thinking about this, what we're doing is building up some mental computation skills that happen there. So it's as simple as that. But once again, you notice the link with the language. I started to use less than, more than, 10 more than, 10 less than. Now, we can make these things just a little bit harder or a little bit easier depending on the language that we use or the numbers that we have. So for example, if we just use 2 6-sided dice, the numbers will always be less than 66. So I'll focus you on the board again and I'll talk about a couple of other things that you can get from just putting a single counter or a number on the board. So let's head back to the board and I'm going to move my counter to a different number here. So let's move to 35. Okay, so here's a question I could ask. So one of the ones is, if I add 10, it's 45. If I subtract 10, it's 25. But let's start looking at the idea, what if I add 11? Well, if I add 11 to 35, it's like adding 10 and 1 more. So if you look at the board, I'll show you what this looks like, and I'll just grab my pen, you see here. So if I'm adding 11 to 35, it's like adding 10, which takes me to 45, and then 1 more would take me to 46. So I'm moving diagonally. Well, let's use the same reasoning. What if I'm subtracting 9? So subtracting 9 is like subtracting, in this case here, 1 less than the 10. So if I subtracted 10, it'd be in this case here, sitting here. So subtract 10 would take me to here. But if I'm subtracting 9, it's 1 less. Now this is a bit tricky because you might want to go that way. But in fact, I'm subtracting 9, it is sitting here. So it's 1 more than the 10. If I was subtracting 11, I would head that way. So you start to see that there's a whole pile of things that you can discover that sit on the board. And we're going to play with some of those ideas now. And it could be as simple as if we had 2 numbers on the board. So let me imagine here that I'll put 2 counters on there and we'll start talking about some of the numbers that come, for example, between. So I head you back to the board and this time we'll be on 43 and we'll be on 45. So there's the 2 numbers that we have here. And I might ask the number, what's the number that comes between that? And some children don't quite get the idea that we're now looking at that number that sits there, 44 and so forth. Now we could talk about the digits being the same. We could talk about the 1's digit always being 4 and so forth. So we're building this mathematical vocabulary as we go along and so forth. Let me just talk about another idea, and it's really 2 ideas in one. And one is the idea of counting, and counting not just in ones. So it's fairly simple to count 1, 2, 3, and so forth. But as we get a little bit older, we want to count from any number by any amount. So for example, let me set this task, and I'll take you to the board, and I'm going to put a counter on 9, and then we'll count by 9s. So it's really the multiples of 9, but you'll see what I mean. So head down here, I'm going to put a red counter on 9, so our starting number is 9. And if I count by 9s, well, my next number would be 18, my next number would be 27, my next number then would be 36, and we start to see some patterns beginning to develop. And if we follow that through, I'll just put some more counters here as well, so we can just spot this. And this is particularly why I like the 19mm counters, because they fit so well inside the board and stop us having some issues. So at the moment, you can start to see, in this case here, so if we have a look, just heading straight away here, we recognize this. I started at 9 and I added another 9 and another 9 and so forth. Or you might recognize it as the 9 times table. There's a few interesting patterns that we could develop here. If we look at this one here, if we're looking at the 9 times table, one lot of 9 is the same as one lot of 10 take 1. 2 9s are the same as 2 10s take 2. 3 9s are the same as 3 10s take 3. 4 9s are the same as 4 10s take 4. So you start to see that idea. You also see this diagonal pattern happening here. And the interesting notion here is, does this pattern continue? So if we have a look here, we get 90, and then we're going to build beyond the 100. Remember we talked about why we like to have the board going beyond 100, and you start to see that the pattern continues as we work our way down the board, and you start to see it's the same diagonal. Now, while we've got this pattern here, let's look at what we call the digit sum. Now, the digit sum is when I add the digits that make up the number. So in this case here, I've got 1 and 8. So 1 and 8 or 18 is, if I add them together, is 9. 2 and 7 is also 9. 3 and 6 is also 9, and so forth. So you start to see that in the 9 times table, the digit sum is always 9. Now you're thinking to yourself, does that always work? What if I go beyond simple numbers? So let's head back to the board. Let's look at the higher numbers and see whether the same idea works. So for example, we've just done single digit numbers. Let's get to 99. Well, 99 is 9 and 9. Oh, that's 18. Doesn't seem to work. But what's 1 and 8? 9. What about 108? Well, the sum of the digits is still 9. What about 117? Well, the sum of the digits there, if you look, is 9. So 1 and 1 and so. So now we start to get that one of the divisibility rules for if you know something's divisible by 9 is the digits will always add to 9. So we're starting to build this number sense or this thinking, and all we're doing is playing with the idea that's sitting on a number board here. So we've got this basic notion of what's happening, this idea of the number board that happens there. So we've looked at some patterns here, and that's just patterns on the 9s table. There are other things that we could do, and we just started with a counting notion. We could also look at the idea of what's called common multiples. Now we did that in the very first exercise where, remember it talked about I'm a multiple of 3, and then I said I'm a multiple of 4. So let's just have a look at this idea of multiples and make some predictions. So head back to the board. I'll use my counters again. And this time we'll go, for example, we could have the multiples of 5. We might show them in red, and you start to see that the multiples of 5 are going to be in 2 columns. They'll be in the column that, in this case here, the column that is headed with 5, or the column that's headed with 10. And we could go a bit further there, so let me just continue that same pattern that we've got here. So we've got some red counters, and we're just continuing down, and you start to see that notion. Now, we could also then say, let's have the multiples of 6. So in this case here, I'll use a different colored counter, and I'll use 6, and then I've got 12, and then I've got 18, and then I've got 24. But what we're looking for, is there a common multiple? And you'll start to see that the common multiple is going to sit right here. It'll be both yellow and red. So you start to see we get the 2 of them. You can offset them a little bit. So we can have the idea of what's called a common multiple there. And the lowest common multiple of 5 and 6 is 30. So we're building that sort of mathematical language. So we started with the word multiple in the very first thing we did. We're now talking about common multiples, so multiple of 5 and 6. And then I added the word the lowest common multiple. In other words, the first one that both of them reach in that sense. Now, just to give you an idea, we can go a step further and we can build this idea of place value knowledge. And the chart helps us, this whole number board helps us develop this idea of place value. So I'm just going to clear my board a little bit of the counters, and I'm going to put some cubes onto the board. You might have spotted them a little bit earlier, but let me show them to you. You'll see them. Now, let's take a really simple configuration. I'm just going to take this configuration of cubes. Now, the nice part about it is these cubes are 20 millimeter, and so is the board, so they fit nicely on top. So let's take something quite simple here. Let's move across here, and you'll notice that I've just covered part of the board, and you can see two numbers there. One of the numbers you can see is 22, and the last number you can see is 28, and we know that they're running in a row. So now what I need to do is get the children to identify what numbers have been covered. And so they need to use their number sense to realize that as you move along a row, each next number is adding on one more. So if we head back down to the number board, you'll see what I mean. So we need to start to identify, well, what's the number under here? Well, it must be one more than the number here. So that'll be 23. And now that's 28. So what's one less than that number? That's 27. So now we could identify it's 23, 24, 25, 26, 27. Now that seems relatively easy, but if you're just learning some of these things, then learning that count idea is pretty significant. But watch what happens when I turn it around, and let's just put it in this spot here, okay? And as you can see now, all I did was turn that around, and now we're going not in ones anymore, but by 10. So I know my first number is 27, and I can work out, well, there's a couple of clues here. It could be 10 more, so it's 37. But if we look back at the board, you'll start to notice there's two other clues. So my number sense or thinking or reasoning about numbers starts to develop. So let's have another look here. So we know that if we add 10 on here, that's where I'm getting 37. But maybe some children haven't recognized that. But if I look at this, there's 36 and there's 38. So the number between it's got to be 37. So you start to use, you can use that reasoning. We can work that way or this way, and you start to see that we could fill in the missing numbers. Now, that sounds pretty neat, but let's get serious here. So I've made another set of cubes, and you start to see how we can combine both. And you start to see that we could have all sorts of configurations that say, well, what numbers are missing or hidden under that set of cubes? And I've got to use my ability to add in 10. And if you look here, so I could add 10 here. So from that one to there, it's 38, and that's 37. Or I could work from this side and say, well, that's 36. If that's 36, that's got to be 37, 38. So there's two different ways that I could work in order to determine this that happens there. Now let's just have a look at another thing. Now, potentially children can make these themselves and challenge each other, or maybe the parents could work with children. But all I've done here is now I've got a different shape, and you start to see how that builds the idea of adding in tens or adding in ones, and you start to see some of that sort of thinking that happens. So there's one idea, and it's just a place value idea, understanding that we're increasing tens or ones and so forth. But here's a really neat idea that I'd like you to think about a little bit. So I'm just going to move my board a little bit so it's a bit clearer to see. And here's one I just made a little earlier that you can see, and I'm going to put it right up here so it's relatively simple. That sits there. And if you have a look, basically what I've made, I'll just show you, I've made basically with cubes this square, but I've left the center out of it. And I'm just going to put it on the board, and you will start to see how it fits. Okay, so what I've done is now covered a bunch of numbers. Okay, that sit there. And you could work out what all the numbers are all around that. So we've made what I'm going to call a number window. Now, it doesn't have to be that small. We can have a larger chunk in the middle. But now I want to move to some algebra or some algebraic thinking. Now that could move anywhere on the board, of course. We could have it in there. But now, just sometimes we think these things are very simple. I would like to develop the algebra that sits here. So let me give you a couple of examples here. So remember the window we just had? And so let's connect a few things here. So let's say this was in the middle. So 15 was in the middle. And maybe I'll put a counter just to make sure that's really clear. That's the number that was in the middle. Let's think about a few things here. So essentially we've made a square, and the square sits like this, and we could just talk about the numbers that are each corner. Now, what I might do to show that is I'll put some red counters in the corner, those two corners there. So here's something I could ask. Well, if I just add 4 and 26, what total do I get? And hopefully we get an answer in this case of 30. So 26 and 4 gives me 30. Now let's look at the other corners. So if I add 6 and 24, oh, that's interesting. I also get 30. So you start to see here, we're just still practicing some simple addition, but now I want to build the thinking that goes with this. So that's interesting that happens here. What happens if we found a different center point and did the same thing? So I'm going to choose a different set of numbers on our board and see whether the same idea works. So at this point here, I'm going to go with, I'll choose 55. So if you have a look on the board, you'll see that I've put a little mark on 55. Now let's do the same thinking. If I now think of this as having a square around the outside, so I can draw the square if you want to see it. So there it is there, that square there. And I add the numbers that are in the corner. So I've got 66 and 44, that's 110. That would sit there. And if I do these ones here, 64 and 46, that's also 110. So that's quite interesting and intriguing. But let's now go back to the original one that we had. So if I go back here, you might notice some things that are happening here. When I added 4 and 26, my total in that case was 30. Do you notice any link between the number in the middle, the yellow number, and the two red numbers? Well, you probably noticed if I double the middle number, I get the total of what's sitting there. Did that work? Does that work here? Well, let's have a look here. 46 and 64 was 110. If I double 55, it's 110. So you start to see now, not only am I doing addition, that I've got some multiplication happening. So there's a lot of nice patterns that sit here. Well, the question that comes to mind is, does that work when I make it larger? And I'm not going to answer that question today. It's something that you might like to expand on. But there's a couple of other things that we might want to think about here. There is a relationship between all of the numbers in that square and the center number. So I'll take you back to what we just looked at, and we'll talk about some algebra that might come from this. So if we go back to the original one I had, you'll notice on the board that, remember, 15 was in here. And if we take those away and we just added up the numbers that are in here, there's a link between the total and the number in the center. Now, I'm not going to give you that answer either, but if we were to add up all the numbers in our square and then compare it with the middle number, there'll be a little link that you might notice. There are lots of patterns that develop inside this sort of square. Now, it's just helping us to see that something as simple as this number grid has a lot of options for us to think about how we might develop that sort of thing. So essentially, my hint is going to be this has a link to the number 9 somewhere. And so does this, if I were to add them up. So we're looking for a link between multiplying by 9 and the total that sits inside there. So we just took a pretty basic idea like a number grid and developed a bunch of thinking to do with it. But sometimes we can perhaps not get the maximum out of things here. So what I'm going to do is I'm going to take this board that I've been playing with. Okay, so it's the same board I have here, and you could do the same even there. But in fact, quite often people don't realize that on the back, it just basically blanks. And so I just want to talk about what we could do with the blank side that sits here. So I'll give you an example. My granddaughter, she's about 5, going on 5.5. And so one of the things she likes to use is use the other side of the board to show me how far she can write her numbers. Now that might seem really basic, but let me just take you through a few simple ideas here. So if you turn onto the back of the board or just a grid, we'll do the same thing. So in this case, what we have here is no longer any numbers on the board like we had there. We can put whatever numbers we want. So if you think about it, we don't always have to start, for example, we could start at 0 and go 1, 2, 3. That changes the board slightly differently. So that's one possibility that we might have. Let's pick another example. Why can't I start at 37? Why does it always have to start with small? And then I go 38, 39, 40. And then you would look at the patterns that might exist there. And of course, what number will I end up with in this spot here? It's about some prediction that might happen there. So what do you think might happen and so forth? So we can make our own boards, but of course, it doesn't always have to be like that. So let me give you another example. Once again, just this idea of number sense and developing. So remember before we started with a number and we counted forwards. Well, this time what I like to do is start with a higher number and count backwards. And I want you just to sort of think about the possibilities that might happen. So on the top left-hand corner, you watch, I'm going to write the number 99. So we're starting at 99, and you might like to follow as we count backwards. Now, we're going to count backwards in sevens. Okay, so if I count backwards in 7, my next number is 92. My next one is 85. And the next one will be, if I start following that same pattern, I'm counting back in sevens. So I count back there. What's it going to be? And you've got to think. Now, here's the next question for you. If I keep going and I keep writing and going backwards in sevens, so remember I'm subtracting 7 to get there, and then I'm subtracting 7 to get there, will I ever write the number 50? So I want you to think about that a little bit. Will I ever write the number 50? Okay, now the next question is, if you think I will write the number 50, where do you think I'm going to write it? Where along here do you think I would write the number 50? So now let's talk a few strategies here. Let's say children are struggling a little bit with the idea of subtracting 7, okay? So let's follow it through a little bit here. It's pretty hard to subtract 7, but it's pretty easy here to subtract 5. So this is the number sense that's coming into play. So if I'm subtracting 7 and I'm subtracting from 85, one way is to say, well, if I took 5 away, I'm at 80. But I've got to take 7 away, so I take 2 more away and I get to 78. Hopefully that becomes fairly clear. I took 5 away, it took me to 80, and then I took another 2, which is like taking 7. So I took 5, and then I took 2, and that gets me to my spot. You start to see the thinking that happens there. And then I could keep going a bit further. So I've taken 7 away. That's relatively easy now. That's 71. This is a bit more involved though, isn't it? Okay. Now, in this case here, 71, okay, taking 7 away from that's a bit more involved. But here I want to just get a bit more thinking, because sometimes people dismiss this really simple material and gear and don't really focus on the idea of problem solving and reasoning. Because my question was, will you ever write 50, and where will you write it? So if I take you back to the board, and we're just on the grid side with no numbers on it, think about what's going on here. So I'll take you into the board, there's 71. Now we're counting back in sevens, and let's think about sevens. If we think about it, 3 sevens are 21, okay? And if I subtract 21 from 71, I will definitely get, so if I've got 71 and I take 21, I definitely get 50. So there's the first answer to your question. Yes, I will get to 50. But where am I going to write it? Well, I'm going to write it in 3 spots further down. So if you think about it, I took a 7 off, then another 7 off, then another 7 off. I will be writing 50 at this spot here. It just shows you how something that seems relatively simple can get quite complex and develop what I'm going to call number sense. Now, number sense really is applying everything that we've learned about place value. It's applying everything that we've learned about basic addition facts, about subtraction, about multiplication, and putting it all together. And quite often the way we put this together is we structure it through the language or the words that we use. So basically in this point here, we're building things called understanding, which is the language and interpreting what I asked, and putting our fluency together with it. So things like your multiplication tables and your addition and subtraction. So basically that's just been a fairly simple overview of things that you can do with a number board. And I'm sure you start to explore some more patterns and so forth, you'll see what I mean about taking a simple piece of equipment. And if you think about it, all we did was some coloured counters, some whiteboard marker, because we had the whiteboard version of the number grid. We put some cubes on it and we started to ask some questions. And so I like to get the notion of the what if question. So hopefully, Heather, there's a few ideas that you could see there that you might want to try even with your own children. But basically, it's a pretty simple piece of gear, but a lot of mathematics can happen with it.
Paul, thank you so much. I really appreciate it. Now, before we finish, I have to ask you, was the question 135 divided by 9 equals 15? The 15 in the middle of the window?
Oh, okay. Yes, yes.
Was it 135 divided by 9? Yes? So you had to add the middle as well.
That's right. So if you add all the 9 numbers in that box, you will find you multiply the center number by 9, it will give you the total. Or you do exactly what you did. You add them all, you divide by 9, it'll give you the number that's in the middle.
I do it the other way because I was checking both ways, and I thought I'm going to ask you at the end. I'm going to do that with my children to see what they say. Thank you so much. I loved that, especially about the language, because I know that's one of the big things that children are finding hard is word problems. So when they get to the age around about 9, 10, 11, they actually start more word problems, and that's where a lot of mistakes are made because it's not the symbols. So thank you very much to the team. Thank you, Paul. I know you've got a team behind there as well. The webinars are always up on the first Monday of the month. And you can go to the YouTube channel for Dr. Paul Swan and also for EDX Education, and they'll be live on Facebook on the 9 a.m. on the morning of the first Monday of the month. So Paul and team, thank you so much. Really appreciate that today.
No worries, Heather. Just one small point, Heather. Any box of 9 numbers will work exactly the same way. If you try it on another box of any 9 numbers, do the total of the 9, and you work out what the same is.
With my child, I think I might choose something like 63 or 78. I'm not going to choose anything with a 5 or a 0.
No worries. Thank you, Heather.
Thank you so much.
Bye.